specific market, but it's another market we can address in the near term. So that's the material we have today. We're out talking to various folks. We've been out some. We'll discuss them later. But something that we recently discovered is something that most people consider the holy grail of optics, and that is the third-order material, and you'll see why here in a minute. We gave that to Lehigh University, and they confirmed these results. They actually did the test of our material, that it responds in about a picosecond, which is a billionth of a second. It's actually faster than that, but that's as fast as they could measure. And they said the results of our material, lightwave material, for a small molecule was 100 times better than anything else they tested. So what does this mean? Well, it means eventually we can get to an all-optical transistor. And I'll remind you the transistor is the foundation of the entire computer industry. Let's talk about how that might work. In the third-order effect, light can actually switch light with no electronics. Let me give you an example. In this slide, the gray material is a piece of glass. Our material, lightwave material, is on the glass. We first bring two lasers in, shown in yellow, and they hit the same spot on the material. They're coincident on the same spot. They form what is known as a virtual mirror, or another name for a hologram. Now, if we bring a third laser in, slightly lower frequency, and hit that same spot, it will actually change the frequency of the outgoing beam with no electronics involved. Think of a 0 to 1 or the change in frequency. In any case, it's done via an all-optical switch. No electronics are involved whatsoever. It's our material and lasers being used to actually change the frequency of the light. That, folks, is a giant breakthrough. We're in the process of confirming this information with a project at the City University of New York where they're building a waveguide using our material to test the third-order properties. Now, I talked earlier about an optical limiter, and basically what we mean, think of a satellite in space. I'm back to these pictures again, the opaque and clear pictures. Think of a satellite in space. The way you destroy those, and one of the ways is a high-powered laser goes up and basically destroys the electronics on board. Think of a limiter that can respond in a billionth of a second between opaque and clear, opaque and clear, opaque and clear. Again, you can see the benefit now of why this would be of interest. The window would be clear, and then when it something hit the window, like another laser from the outside, it could change the from the clear window to the opaque window in a billionth or under a billionth of a second. That has some interesting implications for the U.S. military. Okay, let's go to the vertical trajectory. I talked about that before. We already have the scientific invention, the patents allowed, and verification by third parties. That's the important part. We're looking like a missile sitting on a stand here. We're fueled and ready to go. And as I said earlier, it's going to go very quickly once we get this material accepted by the microelectronics industry. We have some issues we may have to deal with, application engineering fees, we may have to do some science fees, and we may have to develop or provide some prototype material and some device sales initially. But all this leads to a licensing and royalty model for our material. And as I said before, it will go very quickly. Once they accept and utilize this, it will go across their total design process. Why? Because it's cheaper, it's faster, consumes far less power, and it can be put in a flexible form factor. All important issues. So finally, let's talk about the management team that's going to take the company and achieve these objectives. Start off with Jim Marcelli as the CEO. He's increased one company's valuation by 225-fold. He's had several company successes. He's built strategic partnerships. He's done many product introductions, and he's built management teams, which is very important in a young company like Lightwave Logic. Myself, I was the founding investor and chairman of Taser International. When we took that company public, we had 41 millionaires at their IPO. It was our family business, and my two sons one's the CEO and one's the chairman today. That company has total market dominance in its industry. Another company that I ran up in the Silicon Valley back in the 80s, in 1985, we did $8 million in revenue, lost $7 million by plan, and I sold that company for $75 million, which was a watershed in the Silicon Valley. This is before the internet bubble of the 90s. Dave Eaton is our technical guru. He was with DuPont 30 years as a materials scientist. He actually was the founder of DuPont's Photonics Lab. They tried to develop this material with this capability. And he's a world-class expert in polymer-based components, and we're glad to have Dave on board. Finally, Terry Turpin, who is a lightwave computing guru. He really has 30 years of fame in the optical computing industry. There's actually an effect there called the Turpin effect, which I won't go into today. He was with the National Security Agency, NSA, as the chief of their advanced processing division for quite a few years, and more recently with the chief Technology Officer of Northrop Essex Corporation, which he has since retired. So if you look at the roadmap to the future, we have second-order material today for intra-chip communication, which I discussed. Big opportunity, $100 billion opportunity just in microprocessor chips. And inter-chip communication, a $70 billion worldwide opportunity for us to address. There are so many markets it's hard to point out, but these are a few that I've discussed. Third-order material brings us the all-optical switch, all-plastic chip, less power, up to a terabytes per second on modulators, and the chips, if they're all plastic, can be printed. They do not require a foundry. Okay, so in summary, Lightwave has a disruptive and compelling technology. We have second-order material now and third orders in process. Enormous markets. I mean, I've only pointed out two that are $170 billion. There's far more markets out there, but for a small company to try and address those at one time is impossible. We have a growing intellectual property portfolio, and we have strategic partners that we're looking forward to in 2011. We have announced Lockheed Martin. We're working with them. We expect to have one large chip company as a partner in 2011 and one large telecom company. So that pretty well summarizes the Lightwave Logic story as we know it today. If you have questions, I really wish you would address them to me, or hope you'd address them to me. My email address is listed here, phil@lightwavelogic.com, and my cell phone number is 480-280-9192. And it's better if you send the questions to me, and rather than bother Jim Marcelli. He's trying to run the company, and he's busy as heck in that job, and I'd be more than happy to help you with any investor relation questions you might have. So with that, I'd like to thank you for taking the time, and I would tell you that it's been a pleasure to give you this presentation. Again, if you have any questions, please come by or please send me an email or give me a call on the cell.